Okay, so in the last presentation and third session, we have Dr. Matthew Raup, who served as the chief of the business intelligence team at Tobyhanna Army Depot and an adjunct professor of a graduate level class focus on technology and organizational development at Penn State University. Dr. Raup is an experienced IT leader with expertise in business intelligence, end user technologies, user experience, and application development. Our core presenter for this presentation is Dr. Aileen Zaballero. So I'm sure that Dr. Aileen will introduce herself because we have another very interesting, exciting sessions later on after the dinner. Our topic now will be about artificial intelligence, algorithm bias, generating real societal bias. The presentation will be focused on AI algorithm bias that could result in societal bias, the negative impacts of algorithm bias on disadvantaged people, population, and identify the role of organization development in addressing and mitigating its consequences. Dr. Raup, Dr. Aileen, the floor is you, please. Go ahead, start. Thank you.
All right, thank you very much for that introduction. So our objectives today. So we're going to explore the algorithmic bias and its impact on societal bias, as he shared. However, to do that, there's a number of things that we want to discuss in order to make sure that we can appropriately identify that. So we're going to have a better understanding of artificial intelligence and how it works. We're going to learn what AI algorithmic bias means and why it occurs. We're going to identify the impact of algorithmic bias on society bias. And lastly, we're going to be discussing the role of OD and how it impacts with AI. So this is a pretty fast presentation, so we're going to focus most of the time at the end for questions. So what is artificial intelligence? So the book definition, it is science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the similar task of using computers to understand human intelligence, but AI does not have to confine itself to methods that are biologically observable. So what does that mean to you? So AI is all around us. One example is the biometrics with your phone. So it looks at your face and it compares it and decides whether or not it matches a face that it was trained with previously. Another example is the Amazon Prime shopping. So you have to imagine there are thousands and thousands of items out there that you can purchase. And so when you do a search, how often is the first 20 so items or so, it has exactly what you're looking for. So what are the chances that it's able to find that without making some kind of decisions? It is making decisions. It's making decisions based on your demographics. It's making decisions based on what you've purchased before. And it is making decisions on what other people who are similar to you are buying as well. And lastly, even something like Google searching is using artificial intelligence to help impact what you are seeing whenever you're searching something. So again, there is millions and millions and billions of web pages out there. So how is it that whenever you Google something in the first 5 or 10 results, you have exactly what you're looking for? And it's because AI knows you, it knows what you're looking for, and it's making recommendations. So that's pretty cool, but it can also be a little scary, right? Because it's telling you what you're looking for in some cases. So whenever we talk about AI, one of the biggest things that it's important to understand is the idea and concept of machine learning. So machine learning is basically how AI learns. And there's 3 primary methods that AI can learn. The first is supervised learning. So with that, a human provides input and output for learning. So for example, on the right, you see a picture of an apple, and then you label, this is an apple. Then you have a picture of a banana, and you say, this is a banana. So it gives you both the input and the output that's expected to see. Another method of learning is unsupervised. So unsupervised learning is very powerful because you can give it tons and tons and tons of raw data, PDF, pictures, any kind of data. And then it goes through and it looks for patterns. So on the right, you could give it tons of pictures of bananas and apples, and it may not know what's a banana and what's an apple, but it would be able to tell you all the things that look the same. So these things all appear and we know that they're apples, and these things are all similar and they're bananas. So that kind of learning is really powerful because you can put a lot of data in a short amount of time. And lastly is reinforcement. So that's when AI makes a decision and you confirm whether or not that decision was correct or incorrect. So again, for example, you have a picture of a banana. That's not an apple. So when you tell it it's not an apple, it knows if I guessed this and it was wrong, I know next time to change that differently. So all of these provide different learning methods for AI. And it's really powerful when you can combine all of these methods of learning together. So I don't want to bore you yet. I'll wait for that a little bit later. We're going to go ahead and play a little game. So on the screen, you can see a link that we're going to go to. And Aileen is also going to put a link in the chat for you to go to. So if you can go ahead, Aileen, put that in the chat, or put this in your web browser. And you should be able to see my screen right now. Can you see the screen?
Yes.
All right. So it's a game called Quick Draw. And this is an AI, and it makes recommendations based on what you picture, but it also talks about how it learns. So I'm going to go ahead and play this game. So you can play as well. If you don't have access to it or it's not working on your end, you can watch me play. I'd prefer you play yourself because then you don't have to look at how horrible of an artist that I am. But we're going to just take a minute here and go through this. So you can play on your own or you can watch me. So I am making a paper clip. All right, got that. An owl. So these are all random. So if you're playing on your own, you may get different. Okay, a mushroom. 3 for 3 so far. Ooh, washing machine. I'm not really sure how I want to draw that. All right, picture frame. Butterfly. I must not be doing very well because it keeps on guessing that I'm drawing a whale or an elephant. All right, so I did not get a butterfly. My butterfly was not very good. So when you're done, you should probably wrapping up here with that. And it says it found 5 of the doodles. And we can go ahead and we can click on it. You can click on one that you did find, or you can click on one you didn't find. And it gives you an idea of what it was looking for. So the closest match was a saxophone. The second closest match was a squirrel. But if you look at the squirrel, it has like 2 humps. And it was comparing those 2 humps to my butterfly wings. So if I look at some of these other ones, I don't think mine's that bad. But this goes through and it gives you an idea of how that's done. And just to get a better understanding, you can actually go through its database and click, and it'll show you millions and millions and millions of doodles that people have done. And every time somebody draws a picture of an apple, it gets that much better of an idea of what an apple may look like. So this was just an example of the power of AI and how it can learn. And we're going to talk a little bit more about here and how that can also be a negative thing. So what is the goal of AI? And so I'm going to turn it over to Aileen that's going to talk a little bit more about this.
Thank you, Matt. I gotta say, what's actually funny about that quick draw that you did, that means somebody out there thinks an owl has horns. So interesting, but that was a lot of fun. So thank you so much. So let's talk about the goal of AI. So I'd like for all of you to just take a second to think to yourself, what do you want AI to do or not do? I'm sure this answer will vary among all of us, but also varies across industries and also occupations. But generally, just to name a few of the reasons why people are trying to use AI is to enhance human capabilities, automate tedious tasks, and improve decision-making in various ways. But there's one more question to really think about. How should we approach AI? And so when you think about approaching AI, you can look at it from a human approach or a logical approach. Do you want the human approach where the AI system thinks and acts like a human? Or do you want the logical approach where the AI system thinks rationally and acts rationally? So I think the first thing that you got to really think about is what does it mean for an AI system to act rationally? So let's start with that first. The rational approach to AI follows the symbolic logic. Statements that have truths that are either true or false. So an example, if X, then Y, if Y, then Z, then logic follows if X, then Z. It's a very simple mathematical logical piece to follow. The other example would be if I am a human and all humans are mortal, logic would then believe that I am mortal. Maybe, hopefully with AI, I may not be mortal and I could download my brain. But the logical approach follows very explicit rules. And the logical approach to AI involves designing algorithms and systems that follow predefined rules and operates based on a very logical deductions. And more importantly, the decisions don't vary from predefined rules. It stays pretty structured in that. Now, if you try to think of some examples, probably one of the best ways to use a logical approach would be like fraud detection, where they use machine learning to identify patterns and anomalies to flag some suspicious activity. So now let's kind of switch a little bit and think a little bit more about the human approach. And I think a lot of us will probably think of science fiction when it kind of look at that, but let's talk a little bit more about what that human approach is. The human approach is not, can you go back again, Matt? In the human approach, it's about developing not just the capabilities of the AI system, but it allows it to reason, can problem solve in ways that's comparable to human beings. And more distinctly, the AI system is able to learn and adapt to new situations. And that's the big piece, that it could adapt to new situations. A very simplified example would be that I didn't turn off my Siri, so excuse me if it turns on, because it'll talk to me automatically, but Alexa, Siri, and a Google Assist. These systems adapt to the situation by learning how the user interacts with it, and it personalizes it to my response. Every morning, I will ask it, Alexa, I'll tell you so it doesn't wake up, and it did, what the weather will be like. But there are days in which it'll just randomly ask me if I want to know the weather. It'll also ask me if I want to know the news. I didn't prompt it. It just adjusted based on the kinds of questions I asked historically. So when we think about the futuristic idea of an AI, we kind of think of science fiction, at least I do. So Star Wars C-3PO, WALL-E, iRobot, and even Terminator. So let's consider the science fiction of AI that most people would know in Star Trek terms. So for those of you who are not Star Trek fans, or who are Star Trek fans, I'm sorry, the debate of logical choice over human or emotional driven choices can be depicted by Data and Captain Kirk. So for those of you who are not familiar with these characters, Data is an android. We're not talking about the smartphone, but it's a synthetic life form with an AI brain. And Data has an impressive computational capability. It doesn't feel emotions. It doesn't understand human idiosyncrasies, and it strictly operates on logic. But on the other side of the decision-making spectrum, you have Captain Kirk. He operates out of gut intuition. He's capable of even ignoring rules and regulations, which he does often if you watch the programs. He's very headstrong. He disobeys orders to do what he thinks is best. Captain Kirk is also known for his inherent sense of ingenuity and his ability to think outside of the box. But more specifically, the thing about Captain Kirk is that he's able to adapt to whatever situation, whatever planet, whatever condition he is in. And so that's kind of really the differences between Data, who follows rules exactly the way they are, and Captain Kirk, who will modify his actions based on the conditions and what's happening around him. And so we want to hear from you in that sense about what do you think AI should be? So if you think about the future, and one of the main discussions a lot of us are having is the future of work, but even just the future in general, how should AI behave? And more specifically, considering the societal impacts, what do you think is the best approach to AI in the future? Which method eliminates bias? Which method leads to more equity? So if you look here on the slide, there's a QR code. They've been using the QR code throughout this session. If you take your phone, your smartphone or your Android, and you point at that, and then as you're taking a photo, it'll be a small prompt that says Mentimeter. You can click on that and then you can vote. You can choose whether or not you think it should be the logical approach, the way Data approaches it, very, very structured answers, and it follows very strict rules and regulations, or the human approach, more like a Captain Kirk that'll modify and adjust based on what's needed. So we'll give you a few more minutes to answer. And then Dr. Raup is going to share it with you. And it looks like it's even. Holy cow, really? All right. So what's funny about that is that as we've been putting this presentation together for several weeks now, we've been debating this back and forth. And honestly, the more I research anything around this, I keep vacillating between logic and the human approach. But to help you make more informed choices for yourself about kinds of questions like this, Dr. Raup will now discuss what algorithmic bias is. Dr. Raup?
All right. So what is algorithmic bias, besides something that's really tough to say? So I do butcher that word often. So as I say it through this presentation, if I do misspeak it, I apologize. I continue to struggle with it. So it basically describes systematic and repeatable errors in a computer system that create unfair outcomes, such as privileging one arbitrary group of users over others. One of the main parts of it is the idea of this AI bias feedback loop. And I would say this is what makes this topic so important for us to discuss. Because if you don't take any action, if we don't identify this is an issue and intervene, it's going to get worse and worse. And it's because whenever you're training your AI, so we talked earlier about that training data. If that training data is biased, your AI is going to make biased decisions. Those decisions are going to learn or turn into its own data. And then that data also gets added to the list on how it makes decisions. So when you have that kind of loop, it's going to kind of get worse and worse if you don't identify it and intervene. So why does it occur? So it may sound like it's as easy as somebody who's designing it is biased themselves, or somebody's trying to purposely make a wrong decision, but it's a little bit more complicated than that. So we're going to talk through it in each step of the AI development. So the 6 steps of AI development: identify the problem, the data framework, algorithm and model development, training, validating, and deploying. So for the sake of the presentation, we're going to make it much more simpler than it really is. We're not going to get into some of the mathematical algorithms that it takes to truly create AI. We're not going to get into the coding that it takes to make it as well. We're just going to walk through each step and see how that can interact with that. And we're also going to provide an example. So this is a make-up example that we're using to help guide you through that process. And it's not a representation of what we actually think. So we're not actually thinking we have a good idea that we're making for an AI. It's just for learning purposes. So step one, identify the problem. So you want to identify the business case for the AI that's being developed. And to go talk through a little bit about the problem we're going to try to solve, I'm going to turn it over to Aileen.
So I'm going to share a problem that actually did exist, and it actually really happened. My mother used to be an accountant. She was an accountant and was the controller for a transportation company for several years. When she moved to another company in healthcare, she worked 2 levels below the controller, and she had a real difficult time progressing in the company. She believed that she was overlooked for promotions and even received poor performance reviews because of her accent. And that was actually also supported by a blatant statement from her supervisor that said it's because of her heavy accent that there are miscommunications between him and her. So Matt, can you help?
Okay, so given that problem, I'm going to try to come up with a solution that AI could assist with. So I'm thinking some kind of software that transforms the communication that someone's speaking, and it removes the accent. It removes, maybe it changes the words if it's translating. So there's a lot of translators out there, so it would be similar to that, but it would include accents, dialects, and that way the person on the receiving end would hear a neutral speech that's easy for them to understand.
So the person who's developing this AI system, or even the ones who are trying to resolve the issue, may not be aware of the unintended consequences from developing such a program, or even trying to resolve this program. At this point, when you're looking at the problem, the primary goal is to resolve the communication challenge, right? But it appears that the accent has only been the only piece that's been identified as a primary culprit. There is it's really important to critically review and identify the root causes of miscommunication, as opposed to jumping to the conclusion that it's just the accent. And the resolution is primarily one-sided. The focus on the person with the accent is the problem, as opposed to anything else that could potentially happen. And as we all know, communication is very, very complex. It's from the sender to the receiver, and the receiver receiving that message. And focusing singularly on an isolated event, such as an accent, and that small piece can create really big unintended consequences. This may cause greater miscommunication. It could also perpetuate the perception that people with accents are less competent, creating both a conscious and unconscious bias. Dr. Raup?
So on step 2, the data framework, we're going to go ahead and figure out collecting some of the data that we need to create our algorithm. So, what are some of the frameworks that have been used that we can be using in this scenario? So in this specific example, what are some of the language or accents that maybe cause some of the challenges? So we could do some research there. We can look at what are some of the communication styles that are considered standard or neutral. So if we're trying to figure out which ones are causing problems and which ones we should be trying to replicate, that's some of the research that we can do during this step.
So exploring this step of data framing and framing how to address this problem, this kind of framework actually whitewashes or standardizes the language, and again, affirms a linguistic prejudice towards people who speak a different language or has a different kind of accent. And that would include regional. So if you think about here in the United States, you have the very strong Southern accents. You even have the like the New York accents, and that'll just isolate people even more so. And in addition, also the further focus on accents as the primary reason for miscommunication focuses on the surface view of the real problem as opposed to the root causes. The framework of language translation in itself also can lead to errors about intent, errors in the message itself, and potentially create more ambiguity. Dr. Raup?
So algorithm development is where we actually build the solution that we're trying to do. So it establishes what mathematical algorithms are doing. It has like the workflow of making decisions. You're training it and telling it what to think and how to think. So in this example, again, this is greatly simplified. There's a lot more to this in reality. But some of the main steps we would follow in this example is we would need to input audio. So we would have the audio from the person speaking. We need to take that audio first. Then we're going to remove accents from it. We're going to translate words that are needed. And I'm thinking we could maybe remove tone, because I know one of the things I've experienced are when people yell at me or they're condescending, I hear some kind of a tone and then it upsets me. So since we're already doing this work, I think that's a feature I could add pretty easily. And that will hopefully make everything a little bit better communication as well. And then at the end, we're going to output the audio that's ideally very neutral, professional, and easy to understand.
So back to the notion of communication. Communication is a lot more than just words. It's about our tone, our body language, the context and how we're using it. And removing tone specifically can really create more miscommunications than anything. The nonverbal cues that lead to misunderstandings or even hurt feelings can be perpetuated by removing the tone. The selection of standardizing the text and the tone and the language creates this, can lead to linguistic imperialism. And I know that seems kind of crazy, but it really is, because you're identifying one set of language or accents to be the primary, the superior, and also the more credible. Dr. Raup?
So training data is very important. So we've already hit on that a few times today. But basically, we have to provide the data that the AI is going to learn. And for this example, I'd be looking for some neutral audio that is clear and easy to understand. I'd also be looking for audio that's very professional in nature, since the intent of this app is to help people with in a work setting. So some things that I can maybe pull data from is maybe CNN, some TED Talks, and some of that kind of media. I also may be able to borrow some of the stuff from Alexa and Siri. So both of those systems have well-defined neutral tones already. So if I have an Alexa and you have an Alexa, they both sound the same. And they do have a few variations. So like British English versus American English. So there's a little bit of wiggle room there, but in general, they're very easy to understand and very neutral. So I'm going to use all this data to train my AI, so that way it is the best that it can be.
So a lot of times when people think about bias in algorithms, it's usually pointed at the training data, the data that's going in, garbage out. And so to think about it, there's estimated about 6,000 to 7,000 languages spoken worldwide. So an automatic speech recognition system such as this that removes accents can have several problems. If the training data doesn't include a diverse range of accents, the system may not perform well on accents that are not properly represented in the training data. So it's almost impossible to get that representative data of all accents. So the AI system that's trained on a limited data set may not be able to identify words and phrases correctly and potentially create more miscommunications again. Dr. Raup.
So the next step is validation. So we're going to do testing to verify that the AI is producing the expected outcomes in relationship to the problem. So if we revisit our problem, we're talking about accents for causing communication issues. And so that is what we're trying to address here. So I would develop some kind of testing that would see if those different accents are fixed so it's easier to understand. So one of the ways I might do that is having some common phrases. So something like, the rain in Spain is flowing mainly on the plains. So I could have that, have a number of different speakers go ahead and say that phrase. And then we would look at the output and say, regardless of who is saying it, regardless of what accent that they're using, what tone that they're using, the listener would be hearing the same thing, exactly the same, regardless of who is saying it and how they were saying it. So that's the way I kind of set this up to test to see if the AI is working properly.
So the validation step. In the validation step, you're starting to really look at the overall output. Does the output of removing the accents resolve the problem of the miscommunication? Miscommunication happens so much because communication is complex, as we all know. It's a very dynamic process that requires attention, clarity, and a willingness to try to understand each other and listen to the perspectives of others. The communication breakdowns can happen at any point in the communication process, from the words coming out to what was seen and what was verbalized and the tone that was used. And removing these pieces like the accents actually removes a good portion of the communication itself. It's really important to be aware of these potential barriers in trying to select a solution, because it's often unintended consequences that create problems, even though it wasn't planned that way and structured that way. The focus was to support and help this individual, which was my mom at that moment, to have better communication so it helps her in the workforce, but it could actually potentially have greater and more negative impacts on others around her.
All right, so that's kind of the basic steps of AI and how it is developed. Hopefully that gave you a better idea of how the different phases could be impacted by a bias and how that could occur without people even intending it or knowing that it's occurring. So now we're going to talk about some real life examples of bias.
So I know our example was a fictional example, but it kind of show you the steps that people go through, and that also that bias it happens in multiple areas. It's not just about the data. It's not just about the person who's writing it. It's not about even the problem. It's a culmination of all these pieces simultaneously happening that could potentially create these biases. And in that, we wanted to share with you some real examples that are happening in the world today, and some of these examples can be can cause some trigger emotions for you. So we want you to be aware of that. But we are just sharing this data set and these examples so that we're aware of actually what is happening. So the first example that I'd like to share with you, I am a huge Amazon fan because I never leave my house and I just buy everything on Amazon. And so when I heard about this, I was also a little bit surprised. But the Amazon system, it was what happened in 2018. It was reported that Amazon's recruiting engine had developed a gender bias against women. So recruiting for their workforce, and the system was designed to analyze resumes and provide recommendations to the hiring manager. But it found that it preferred male candidates over female ones. One of the examples that was stated in this report was that in 2 cases, just the word woman had a negative impact on someone's rating.
So what actually happened in this case is that the training data, it used the unattended, unsupervised learning method, and it used the 10 previous years of hiring practices as what to emulate as the right way for hiring. So that bias existed in the 10 years prior, and when they brought that data in, it kept that data with it. So in the case of the 2 women where the word made it a negative for their application, it didn't know whether they were female or male, but it did know that things in the resumes like a women's lacrosse coach or went to a women's college were identified as candidates that weren't successful, that weren't selected. So nobody made those decisions or trained it to do that. However, the biased data that it had been using for the previous 10 years, that's what caused that to occur.
Okay, so the next example, and this one had a trigger for me as well when I first heard it. It's called Predpole, or predictive policing. It's an algorithmic system that uses historical crime data to predict where future crimes are likely to occur. And if it sounds like Minority Report, a movie that came out several years ago, it kind of is, I think, in some ways. The system was designed to help the police department allocate their resources for more effectively and in order to reduce crime rates, but also to be able to manage the limited resources they had. Predpole sent police to minority neighborhoods more often than any other neighborhood.
So what occurred with here is the feedback loop. So you had data that said you had somebody that was arrested here before, so therefore this is an area where there's more likely for crime to happen again. So it would send police there more often. And the more times that police were sent there, the more time you have data saying, oh, they arrested somebody, there was crime that was taking place. It doesn't mean that crime wasn't taking other places. It doesn't mean that those other places were less risk. However, that feedback loop took that data and it was training the AI that says, data has been found here, therefore it predicts that it's going to be more risky in the future. So that feedback loop is what caused the issue, and it can be a very dangerous thing.
Next example is facial recognition. So there's two examples that we're going to share with you. The first one was in 2009. Nikon used a facial recognition system for a blink feature for when taking photos. And this feature was set up so that if people blinked their eyes, it wouldn't take pictures, because you know how often you'll have a photo with your friends and their eyes are closed. Well, this was supposed to prevent that. Well, the issue was that Asians, such as myself, wasn't recognized as having our eyes open. So it never took our photo. And it's actually kind of funny because I'm not in a lot of photos, and that explains it now. The other example is in 2015, and this one is a very touchy example, but Google Photos launched a new feature that allowed users to automatically tag their photos. And they were using these image recognition technology that allowed people to say, yeah, all these photos on the line, these are me. But the problem is that it also tagged some individuals as gorillas instead of human beings. And that actually did happen. I didn't believe that, but that's crazy, but it actually did happen. Google did quickly issue an apology and promised to fix the problem. That happened back in 2015, and it was reported in 2016.
So in that case, again, as we've kind of talked about, was there somebody making those decisions? Was it an issue with, what steps? And it goes back to that training data for a lot of it. So when minorities have less training data, there's less for it to learn. It's not going to learn as well. It's going to be wrong more often. So that's a really big issue for minorities. And the other part, there was actually some more technical issues as well. So for example, camera quality issues turned out to be a big part of both of these issues. So lighting and how lighting works on darker skin whenever you're using a cell phone camera. Not all cell phones have great cameras. I know they've come a long way, but there's technical reasons, and then there's the AI development process with the training data. So it can be a very complicated issue whenever you're kind of looking for that root cause.
And the last example we have for you is about Tay. When Dr. Raup shared this story with me, I laughed. I thought it was crazy. I'm not a Twitter person, so it was also hard for me to quite grasp. But in 2016, Microsoft released an artificial intelligence chatbot named Tay on Twitter. Tay was designed to learn and improve its responses by interacting with other Twitter users. However, within the first few hours of its launch, Tay began making racist and genocidal comments attacking Jews and minorities.
So in this one, Tay learned from its interactions with people. So it was the unsupervised learning. As it interacted, it would learn to replicate the people that it was speaking to. So there was a unified hacking attack where all these hackers came in with all saying the exact same things. So with all those people saying this is normal language, Tay learned that to be normal language. And so, in addition to all of the normal mistakes that can occur during the process, having people out there who are attacking and hacking the systems adds additional risk as well.
So we've shared with you several specific examples of some bias that are created and existed from an AI system that's been launched and used actually publicly across. The intention, whether or not it was supposed to happen, whether there was more nefarious reasons, there's no way we can really say, but it actually happens. And as consumers, it's really important for us to be aware. There are also several areas where it becomes a high risk for societal bias. That would include school admissions, when students are applying for colleges, job applications, which we already talked about with the Amazon example, insurance rate, housing applications, and credit scores. With these, the algorithm may exclude qualified candidates mainly because they belong to a certain group, or they may favor a specific candidate just because they match a certain profile, or they may be unfairly penalized because of being part of a minority group or of low income. These are some of the things for us we need to continue to ask these questions and make sure that we're aware of why and how it's happening, and not allow AI to just be, to just go without even asking those questions. We really just need to be more aware of all these potential biases.
All right. So in addition to all of those challenges, there's some additional challenges that I'd like to bring up. So one of those challenges is human nature. So sometimes with AI is made off of data. And instead of you always telling AI the data, it monitors, it analyzes, and it looks at all the inputs to come up with data on its own. So that can be a really good thing from a learning experience, but it can also be a scary thing because it's a little bit more real than maybe data that we're used to. So for example, if you ask me how often I work out each week, I might tell you I work out 1 hour a day, so I like to stay active. So that is what I work out. If you were to ask my Fitbit might tell you I work out 3 times a week for 30 minutes. And the reason for the discrepancy is my Fitbit tells me when I actually worked out. And then in my head, that is my ideal. How often do I want to? How often do I try to work out? And so sometimes we don't like to hear the answers when it comes to AI, because that data is scary. It makes us upset. It's not something that we relate with. It can be very frustrating. So another thing that's challenging is we're starting to get to the point where we should filter the data. So if we know that the training data, crap in, crap out, we should filter everything and only put in data that we're good with and that we're comfortable with. Well, Yannick Kilter is a YouTuber, and he trained an AI bot using 3 years of data from 4chan message boards. So if you're not familiar with those message boards, anything and everything can be said other than stuff that's illegal. But it can be offensive, people's true thoughts, feelings, everything is on the table. And what they found is that AI bot was much more accurate in interacting with humans than other bots that were used with training data that it was more tightly configured. So for example, if we want an AI to give its honest opinion, so Matt, does this shirt look good? Well, if I'm training it with data that's only positive and friendly and filtered, it's going to be like, yeah, Matt, you look great. And in reality, this shirt may not match. So when we're talking about AI and having it make decisions and make recommendations, sometimes having real data, or like a real human would, as humans, we have good and bad. We have negative and positive experiences, and all those experiences help form who we are. So from an AI standpoint, having that wide range of information can be helpful. So I know we've talked a lot, and there's a lot going on with this, and a lot of it seems negative, like it's scary. AI is making bad decisions. It's doing all these negative things. So what can we do about it? So the first thing is if you look at all these dates, in the last year to 2 years, there's a lot of laws and things going on. So there's the AI regulatory sandbox in Spain, and that's providing an environment for AI developers to share data, to share best practices, and to really build together to avoid some of these AI biases. There's also the Artificial Intelligence Liability Directive. And what that does is if somebody is biased against, if they're hurt by a decision that AI had made, they have legal ramifications. So that's the first that was able to take place. Algorithmic fairness in employment. That makes sure that all of the people who are using AI algorithms for employment decisions are meeting federal civil rights laws. And lastly, several state laws are coming out that allow people to opt out and reclaim their data. So a lot of these harmful decisions are being made based on data about somebody. That could be current data, it could be old data. So it gives people more control of the data that's out there on them that could potentially be hurting them. And so one of the things that's a new trend that's out there is this idea of this AI and human hybrid. So I've only really started seeing this in the last few months on products that are going to be available for everybody to use this year. So the idea of this co-pilot versus autopilot. And the idea is that AI could do the job completely and it's going to save us money. So that's why AI was a good replacement. It makes good decisions, it's quick, and it saves us money. But now we're getting to this point where, well, if it's an AI and a human, the human could be there to make sure decisions aren't that bad. And it can also help train it as well.
So now we'll wrap up this whole discussion of AI bias back to us as OD professionals. What is our role as OD professionals in implementing and directing AI? In 2019, there was an article from Forbes, and it stated that artificial intelligence in the workplace, how AI is transforming your employee experience. It's everywhere, and we know it, and it's changing things so fast and so quick. And I know that whole adage of, we're in a highly volatile, unpredictable times. Well, I read another article, and it was really interesting. It said AI is enabling change on steroids, and it really, really is. If you think about the discussions that we've had just the past few weeks about ChatGPT, how that's impacting school, how are we looking at it to in terms of journalism, in terms of writing papers, these things are now becoming a big issue and question. But as OD professionals and as change agents, we can help organizations to examine AI from a humanistic value position, exploring the organization-wide and system-wide impacts at all levels of the organization, including the structural impacts and the cultural impacts. We can explore the unintended and the intended consequences from implementing AI and how maybe it'll impact others that we don't even know about, how it may favor candidates who match a certain profile, how it may unfairly penalize certain groups. The OD practitioners can also work with organizations to develop strategies for ensuring that the AI system and the processes are not only working, but it's also inclusive and reflective of the diversity communities that they're serving. They can also help organizations develop collaborative approaches to AI. Dr. Raup mentioned earlier about this co-piloting idea. I think that's also a really important piece to look at it, whereas AI is not going to replace lawyers, but lawyers are going to be using AI to become better lawyers. So also OD practitioners can help organizations develop the change management plans for implementing AI as it's being introduced in our systems every day. Developing a communication plan, training programs, strategies for managing resistance to change and resistance to AI. Ultimately, I think when we think about it, AI is changing and transforming the employee experience. It's changing us as OD professionals, but I think it's also important to look at it as AI is about investing not in the technology, but more about investing in the people who have the skills to not only implement, but also work with AI systems. And with that, I'm going to pass it back to Dr. Raup, who is going to close our discussion today.
So Aileen and I have spent the last few months discussing and debating this subject. It is a very complicated discussion because of the technical complexity and the sensitivity of the subject due to the impact and consequences it can have on the society. Our personal opinions have kind of changed back and forth through our conversations, and I hope this presentation has challenged your opinion and perspective on the subject. So with that, we will open it up for questions. All right.
I hope you guys have questions because I still have lots of questions.
You know, we can fill the time pretty easily ourselves, so we're trying to talk fast.
Let's see, anything come up?
Yeah, I want to ask regarding like ChatGPTs and AI assisted writing problems, because we are all researchers and kind of engaged in the writing stuff. So with the I usually use the I use the ChatGPT a lot, many times, and I kind of depend on that one. But the problem of that is it pretends pretends a human. It pretends a human being, like so even though it's our input, so human input some information to the ChatGPTs, but the generation about what they made is kind of originated from the human. So so what I want to say is I'm sorry.
That's okay. You know, the debate about ChatGPT is really at the forefront right now, right? I mean, you can't not hear news who's not talking about it. But one of the things I remember hearing, it's almost like our calculators, right? There are times in which we're taking tests and they didn't want you to use a calculator. But now almost every math program that you're taking in class has you work with a calculator. It's kind of the same thing with ChatGPT. It's not going to go away. I think for us who are using it, we need to be clear about the limitations, need to know what the range of data and where the data is coming from, and also how it is condensing some information that may not necessarily represent what you're asking and what you want. It's all going to be driven by the kind of questions you're putting in the queue, right? And that queue, if you just moved a word, and it's almost like our accent and translation, if you move the before or after in just one different place, you'll get a completely different answer. And I think it's important to be aware of that in regards to how you use ChatGPT. Dr. Raup, what do you think?
Yep. So when you were talking, one of the things that popped up that's been a big part of our conversation is AI capable of truly unique and creative thought? So the ChatGPT that you're using has all been trained using documents and writings from people before. So when it's making recommendations on what it should do, I know there are some examples out there where the AI is making music and all that kind of stuff. Mm-hmm. So all of the creativity that it's doing, it's just combining thoughts of other humans all into one area. So there is creativity and there is uniqueness to it, but that uniqueness is still based on that human input. So I know that brings up a lot of questions about like copyright. So if it takes the works of 10 different people and it turns it into one on its own, is that truly unique, or is it hitting all those things? I don't know if there's a right or wrong answer with it. As you said, there's a lot of stuff going on right now, and being involved in higher education and stuff, I don't think there's a lot of rules yet on what's allowed and what's not allowed. If you have the ability to program a ChatGPT, and that's a skill that you have, should that be a resource that you can utilize when doing your assignments? So it's a great question. And I don't think that there's necessarily a right or wrong yet. I think that's going to be part of the fun learning through it.
I heard
exactly the same. Yeah. So to bring back my question into that, so it pretends it's like it pretends a creative, like even though it's the combination of the human beings collection, but it looks like creative. So we use it very easily and just copy and paste. But the afterwards, it turns out it seems a cheat. So as a researcher, we should have been more being thoughtful to that perspective, but we usually lose the tight some kind of perspective of that what should I say? I'm sorry. Plagiarism, yeah.
I think in terms of, this is where, especially for educators and professors and instructors, is important for them to take a look at how they're going to address and handle that. I was listening to an interesting podcast of this professor. I can't remember which university was that. He goes, I'm not going to try to stop my students from using ChatGPT. He goes, but I am going to implement it in my system, in my program, in my classes, where I'm asking them to start exploring the kinds of questions that they're asking, and taking and examining how different questions can create different outputs. So I think there's a lot of different ways to address it from a education perspective, but it also makes it, we need to be more conscious now about what kind of information is coming out, right? Garbage in, garbage out. We don't know unless you validate and verify.
Right. And we got the red mark of death that we need to end.
It's my fault. Sorry.
Yes.
Yep, that's good. And I know we didn't provide that much time for kind of that question and answer, but I know that my email is in the chat.
Exactly.
And I'm really passionate about this subject. I also teach a course on it, or not just this, on all IT within OD in the fall semester. So that's something that if you're interested in. And then, like I said, reach out if you want to talk more on it. Thanks.
Thank you very much, Dr. Raup and Dr. Aileen, for this interesting, very exciting presentation. So now we have the time to start the dinner break. So it will start from now till 5:55, and then we come back. We're gonna come back to the main room. So we'll be having only the main room. There are no tracks after we come back from the dinner break. Thank you very much for everyone for attending. See you very soon. Thank you.